Hey guys, wake up. Okay, so let's start with this Packers labs. Okay, so here we're gonna be dealing with a basic UPX Packer, and the idea here, guys, is not to show you how to unpack UPX. Obviously, it's very simple. But the idea here, guys, is start from the basics, following our Carnita methodology. That's the idea. Because at the end of the day, we don't care if we have UPX, ASPAC, or call it VM Protect. At the end, the methodology is what matters. So we're going to start with this basic one, and then we're going to move to more advanced, okay? But it's important to follow the methodology, okay? So what we have here, guys, is we have a binary, which is UPX. This binary ESPS exec. That's a sysinternals from Microsoft binary that I just packed with UPX. Okay, so I want to run it so that you can see the output, so that when we unpack it, it should run exactly as it is run. It is running packed and unpacked. Okay, so here I just do Control Enter to select that file. This is, by the way, this is FAR editor, pretty recommended. Control O to maximize the window, Enter. So you can see there is, the PSExec, sysinternals, and then at the end has these error codes, whatever. Is the output that I just want you guys to keep in mind. Okay, so next step, I'm gonna load it in IDA. Okay, so we go to that place. As you remember, we are using IDA free version 7. It obviously says that the import address table is located outside of memory range, which is normal for packed files. We load it. We see that we have really few functions. We see that there is no import, which is also a good hint of packed malware. I mean, in this case, not malware, sorry, packed binary. Okay, so let's start with our methodology, right? So the first thing we said is that we don't care about the code. We just care about the flow. So here we see there are two chunks, and we can see that IDA can give us this flow pretty cool. That's why I love IDA view. This is the view of a debugger, normal debugger, right? As I was telling you, you go one line by one line, and you can, it's very hard to see here the flow. But this way, it's pretty cool, especially when you are going into more difficult logic. Okay, so we can see that here there is a return here, so this is the exit, so there is just one call here. So we get in there, and we can see here that there is some code here. Again, I don't mind what is going here, I don't care. My methodology is just go straight, try to find dynamic calls. We can see there is a loop here going down. We can start seeing another loop here, keep going down. We need to start looking for any calls going outside, but any calls, dynamic calls, trying to jump into another place. So we can see here there is jump. At the end of the day, this whole code keeps going down, right? And the left side, we can see the whole execution flow so that you can move faster. So here we can keep going down. There are some loops here and there. Still, I don't see any return or any call. Interesting one. We keep going down. We now have two paths here, three paths, left, middle, and right. Okay, and then finally we reach the end, and we can also see here in the graph that this is the end. So in the left side, in this branch, we can see that is just another loop which goes back, right? So nothing to follow here. Then in this other one here, we can see that it is calling something which is dynamic, and it is going to this place. So what is that place? 14008. Let's do Control S to see the sections in memory, and we can see that this 14008 belongs to this range. In other words, looks like these two sections, just something before that, UPX has UPX1 where it executes the code, and when we do Control S, IDA points us where this code is located. So right away, IDA tells us you are in UPX1. So this whole code is in UPX1. And eventually, this UPX1 is going to unpack the code into UPX0 and jump there, okay? But that's the way UPX works. We don't care because we are agnostic to the packers, okay? So we are just following our methodology. However, we can see here that this 14008 is definitely jumping here. So we don't know at this point if that's because it's going to jump into another stage of unpacking or what's going on, right? But anyways, we put a breakpoint here because we don't know what it's going to take, and we are doing this fast. On the right side, we can see that here there is a loop. You know, there's a loop here going up and down, and then we can see that eventually it's going to write something here in RBX. So it's going to move the content of rags into RBX. This move, guys, is very important because, as you remember, we are trying to find the decoder stuff. The decoder stuff is normally a loop, definitely, and in that loop you can see copied into memory. So the fact that you have a square bracket in the left side of the operand move, that means that the content is going to be stored in that memory. That's telling you it is copying into the address. That's exactly what gives us a hint that here is copying something. The question is, where is RBX pointing to? Let's put a breakpoint here. And finally, we can see that in this loop, eventually, if it doesn't take the right, it's going to take the left one, which is here. And eventually here, it's going to jump into this guy. This guy is 14000AA. Again, we check it, and we can see that this 14000 falls into this space. This is great because this is basically telling us that this jump is going to go back into this section, which was empty at the beginning, and that tells us that something is going on here. Okay, so let's debug it. I'm going to put a breakpoint here also, and let's try to debug it. So we go to debugger, start process. It says if you want to run it, and if you are sure. Obviously, this is not a malware, but anyways, guys, anything that you run in the labs, always run it in a virtual machine. We say yes. Okay, we eventually stop there. Just let me clean these windows a little bit. We don't need this now, so here we are gonna put the stack. Okay, so we are here. How do you know where we are right now? Well, you can see here in this purple color, it is highlighted. Also, if we do options, general, line prefixes, so that we can add the addresses in the graph view, you can see that this ACA1 is the same as this RIP, which is instruction pointer ACA1. So there are different ways to know where you are in case you get lost. Even if you are here suddenly, for example, in this area, and you just forgot where you were before, you just go here and RIP, right click, jump, and it's gonna take you wherever the instruction pointer is pointing to. Okay, so where is this RBX pointing to? We can see here that it says 7F F6 6B. Okay, 7F F6 6B. Let's do a Control S. And we can see that 7F FC6B is right here. Okay, 7F F6 6B. Actually, the one below is the same. 7F FC 6B 6B. Okay, what else? What is the next byte? It is 6B87. So here it is 6B 88C, and here above we have 6B86, which basically means, guys, the code is being copied into this address, as we saw in the static analysis, which is great, right? So if we click on play, if you check RBX, sorry, yeah, RBX, you can see that RBX keeps incrementing B5F0, B5F8, 600, and because it is in the loop. So I'm going to remove this breakpoint with F2 so that we can just get out of the loop, and then we're going to see if we land here or here. Play. We see that now it stops here, which is what we were expecting. So now, as we remember also, this address points to the UPX0. Let's confirm that. We do F7, then we ask IDA to tell us where we are located right now. We do Control S, and IDA says you are in this range, which is exactly where we were expecting. So this is potentially the original entry point. As I told you, if you are doubting, if you are not sure, you can always dump it, open it in IDA, and see if you get now more functions, more imports, which is basically the idea. So let's do that. I'm gonna just copy this, it could be the original entry point. Copy. You can even, rename this as OEP, original entry point. Okay, and now we fire up our Scylla 64 version. We go here, we find our executable, which is here. Okay, so now we tell the tool an address which is close to where it should be the import address table so that it can look it up. We said look it up. It says I'm gonna do an advanced search is fine, and it says okay, I found it. Then we get the get imports, and you can see that now we have all the imports in memory. We located it, which basically means it's a good chances that this is already unpacked. So you can click here and you can see all the different APIs. Okay, now the next step, which is pretty cool with this tool, is that now you have here the dump version, which Imbrec didn't have, if I remember well. At least the version that I had it before, it didn't have it. So you can basically dump it from here. Okay, it already put the dump new name so that it doesn't overwrite the original one. We say save. It is saved. Then we do fix dump. It asks us for the dump file, so that is the one that we dump, and there is gonna fix this import address table located that it just found. We say open, and we can see here that it says import rebuild success. Okay, so we're good to go. That's it, guys. So let's just confirm that we have this working, right? So we go here to the latest guy, Control Enter to select it, pipe more, Control O to expand this window, enter. Oops, didn't work. Didn't work. I'm an actor, guys. I'm not only reversible, I'm also an actor. So basically this is obviously planned. So something happens, right? It's not working because we were expecting to have this whole thing, exactly the same output, and we are not getting it. So let's see what's going on.